Hello and welcome to the channel. So we've got a Vox AC30 here. This is a 1990s one, and this is a well-gigged amplifier, and it's got a few noise issues. So we're going to power it up first of all and just see what problems it's got, and then we'll open it up and have a look inside. Right, we're up and running. My word, that is noisy. Just check the lights aren't affecting it. No, everything goes on anyway. Right, let's turn all the knobs. Well, that's with everything turned down. Ooh. See the tubes glowing away, and of course we've got the rectifier tube with the standby switch again, but we won't get into the standby switch debate. Right, I think we better crack this open and have a look, hadn't we? Because a bit noisy, and we've got some crackly pots and things, and we'll probably need to put some diodes on that rectifier socket to protect the tube. Right, we're looking inside, and we've got it fired up. We've got the current limiter on it. Now someone's fitted those diodes on the rectifier socket, which is good. So standby switch is loose. Oh, the irony. So I need to have a bit of a look around in here, because this amp is noisy. Now that could be it could be a preamp tube, could be a number of things. So I've just spotted something else. I bet if Jeff's watching, he spotted it. And Gooden, I've just spotted it now. I've got these glasses, 4x glasses on it. Just lean over, it's in focus. Look at this wire over the cathode resistor. My word. Not a good thing to do that. Should these tubes, one of these tubes start to red plate, these get a lot of current draw on them and get red hot. And that looks like it's been done at the factory, you know, because they look factory to me. But obviously it's had a tech in here, so that looks like factory soldered, so he's not done that. Probably just missed it. We need to look at that, don't we? Mind you, again, where do you route it? You know, but guys probably looked at it and thought, well, not really much you can do with that. But I'm going to do something with it, because that's not, I mean, it's not burnt, it's not, there's not been a problem with it or anything, but it's not good. So we'll see what we can do about rerouting that. But not much other than that. I mean, we can check the bias, see if it's running hot, see if one of these tubes has gone down or something. Could be, could even be that. Could be a number of things. So it's always sometimes a little bit awkward when I'm filming. So somebody made a comment, and I have not replied to a lot of the comments yet, and I will get to them. I've just been so busy. So somebody left a comment saying he was chuckling at the amount of glasses I'd got on the desk, and I have got various strengths of glasses. So when I've got those 4s on like I've got now, if I'm stood looking through the camera, looking over the amp, it's blurred, so I have to lean in. So again, you know, things like that, I tend to spot them when I'm working on the amp later when I'm not filming. But I did manage to spot that because now I've got a pair of not as strong glasses on, so now I can see all the PC board clearly, and I can see that. So sometimes I miss things when I'm filming because it's simply not in focus, because I'm trying to look down the camera at the same time. The camera's right in front of the amp as well, so it makes it awkward for me to lean in sometimes. Because what happens then, if I lean in too far, then you've got my bonce in the way and you can't see anything. So yes, all a bit awkward sometimes filming. Now I say we did one of these a while ago, similar era. In fact, probably about the same really. And we on that one we dismantled the standby switch, because as I say, you shouldn't really have one with a GZ34 rectifier. It's slow start, and those diodes are put on there to protect the surge on the when the standby's clicked in. So it's good that the you know, the last tech that looked at it's put those on. Excellent. So I think the best thing to do now is fire it up and just check the bias, just check these tubes and just see if one of them's gone down or something, and that's what's causing our humming. Although it does sound more preamp related, doesn't it? But we'll check it anyway. I mean, it's had we'll have a look on the underside, but it's had all new preamp tubes in it, and I think the output tubes, they are looking a bit so if we come down, see if we can see in there. I might have to go handheld because I can't get the camera low enough on this tripod, so just bear with me. Right, so we're looking at the tubes there, and you can see the output tubes. If we go across, can you see how the paint's going white on them? So that's telling us that they are running too hot. They've had some bake, they have. Yeah, oven grilled those, so we need to check the bias. I need to check my notes as well, and just see what we'd, sorry, just click that, sorry. I need to check the my notes, what I did on the last one as well, but I think we may be just altering the bias on this one. Right, I'll just get back on the tripod. Yes, it's eyesight is the joys of being in your early 60s. And you know, I went out a couple of weeks ago, and I was out and about, and I think I must have jogged about 2 miles in the day. So I'm a really fit guy, but you can get yourself mega fit in your 60s, but you can't improve your eyesight, unfortunately. I'm afraid that's just no can do, and it'll only get worse as I get older, and this will probably become more difficult. I'll probably get to 70 and I'll be as fit as a butcher's dog, and I'll have one of those giant magnifying glasses in front of me on some kind of bracket with a dome around my head. But alas, poor Yorick, let's press on. We need a meter, don't we? I'm waffling again, and we haven't got time for waffle because we need to get to the bottom of what's wrong with this amp. Could be a capacitor, of course, but it could be a lot of things, so there's no point speculating. I think the first thing we need to do is check those tubes because they are on fire. So right, just thinking about the best way to do this. So we swap glasses again. bring that into the shot where you can see it. And I'm sure if you wear glasses, you've already got them on, so otherwise you won't be seeing any of this video. Yes, we've got him there. He's plastic, so there's no problem. Inductance. So let's go for pin 7. And we've got 260 there. Yeah, plate voltage on that side. Let's see if we've got plate voltage on the other side, because of course we could be missing plate volts on one side of the transformer, and those tubes have got baked a long time ago. 258 on there. Yeah, that's all good. So let's go back and check the screens. 254. 254. 254. Let's just check the other one. Hone in. And yeah, 254. So that's all good. So what we need to do now is go across this, and bearing in mind I've got the current limiter on as well, so I'm just going to flick it off the current limiter while I check the volt, and you can hear the humming come up there. What's going on there? Yes, there's a bit of rumbling there as well. Yes, let's just have a bit of a listen to that. Oh dear. Well, don't know if you can hear that over the oh, there we go. Oh yes. My days. That is on the that's on the Brilliant channel. So it's not so brilliant at the moment, is it? What's that, a resistor, do you think? My days, that is noisy, isn't it? Not many. Could be a tube, of course, but we'll have to check that. So yeah, so we'll turn that down now. So that we've got a couple of noises on this then. So let's turn that normal. So the Brilliant channel doesn't have the hum in the background, I don't think. Can't really tell with that going on, my word. You can hear that motorbike going up there. That, I think that's the Village Idiot. Everybody's got one. He rides up and down. He was riding up and down at 3 o'clock in the morning on that. Was rather tempted to go out with the 200 watt soldering iron, but obviously the power flex wouldn't reach outside. Just give him a jolt of heat. Some strange things happening. So we've got two channels and two different noises. We've got one humming and one that's well, rumbling. I think we could call that rumbling. Ah ha ha! I know what that is. I've just spotted it. I bet you diamonds that I know what that is. It's our old friend, the mica cap, and there's two of them sat there. Yes, I bet you. In fact, there's 3 of them. I've just leaned in and got into focus with the glasses more, and there's 3 of them. 1 for each channel, maybe. We need to get a schematic, don't we? I bet that's what that is. Yes, that's got it written all over it. Definitely. So we've probably diagnosed that, and there's another one here. So that is kind of speculating, but I think everybody knows the problems you get with those. So that means, actually, has the board got to come out on this one? We might get away with that, but there could be other things yet. But that, I bet you diamonds, we need to find out which one it is as well. Right, where was I? Before I was rudely interrupted by that noise, we decided to patiently wait. 9.76 on that one. See what we've got on this one. More or less the same. So 9.76, that's the drop across the cathode resistors. Oh dear, 9.76, and that looks like 100 ohms to me. We're only looking for, I mean, we should measure them and get the exact reading, but I think looking at those tubes, I think the exact reading is irrelevant. I think a window is what we're looking for. So 9.76 across the resistors. So we divide that by the value of the resistors, and that's 100 ohms. And that is 97 milliamps. But then we have to divide that by 2, because of course we've got 2 tubes on each side. 48.8. Let's take away 5% for the screens. And now we need to times it by the plate to cathode voltage. We've got 46.3 there. What we need to do now, and I'm going to come in on this side so I don't protrude the camera so much. We'll move that to there, and I'll lean in with the glasses on. Cathode is 3, pin 3, there's the cathode, pin 3 there, and the plate cathode. And ooh, we just can't, 323.7. 323.7. 15 watts. They're on fire. They are on fire. Yeah. Now, if they were Mullard tubes, I wouldn't be as concerned, but as they're not, the JJs, and you can see that they have been run too hot. So that paint, for all those that don't know, that red paint on the tubes, the JJ label, it's temperature paint. If the tubes are run too hot, it turns white. And the reason they do that is because if someone just throws them into an amp, as i.e. this is what's happened with this one, if the paint turns white, it voids the warranty. And as I've said many times on this channel, people say, oh, it's cathode biased amp, just throw them in. No, you can't do that. Now, the last set of tubes that came out of this, they may not have drawn as much current as these tubes, so they were fine in there. People think that only applies to fixed bias. It doesn't. It applies to cathode bias. I've done loads and loads of tests on this channel, and if you've watched the channel regularly, you've no doubt watched most of them. So I don't care what anyone says. It's irrelevant whether it's fixed bias or cathode bias. You must check the bias each time you put tubes in it. So 3 faults and counting. Oh, and then the standby switch, so that's 4. We'll check the tremolo. And we've not even got a signal through it yet. They're just what we found even before that. Right, we need to get this board out, and then we need to do something with that. It's switched off, but I'll just pull that out. So where's that wire going? I think that's a ground. It is a ground. It's a ground wire. So that'll be the ground for the cathode resistors then, probably. Yes, it is. So which way can we route that? I reckon there's room. If we unsolder that, we might be able to bring it through here, do you think? Around the back of these capacitors and in there. There's got to be better than over the top of that cathode resistor. That shouldn't be a big deal, should it? Sure, we can sort that. Yes. In fact, let's unsolder it, because we can unsolder it from the top and have a bit of a measure. We'll have those tubes out and test them and see if they've got any gumption left in them. Screen resistors, another problem that's just come back to me now. Remember, screen resistors. So here we've got 100 ohm screen resistors all the way across here. I've also been a bit of a plank because I'm afraid the printer's run out of paper, and which means it's going to be awkward. I have to view the schematics on the tablet because I'm a plank and I let it run out. And that plank moment scores 95 on the plankometer. They are the screen. I thought they would be, but it's always good to check. So I think what we'll do with those... Oh no, we can't on this, can we? I was just going to say I could put them on the tube socket. You can't on the L84s. No, you cannot, because there isn't a spare pin to put them on. Pin 6, as you can see on those tube sockets, is unoccupied, but he's internally connected, and so is pin 1. But what we could do is upgrade those slightly, because 100 ohms is, quite frankly, is way too low. So we could up those, and in actual fact that would help protect the tubes as well. So let's unsolder that wire. Just make sure this iron's nice and clean, because we don't want to put any gunge on that board. I don't know whether I can do this without burning it, but we can always remake it again. I mean, the reason I want to get it out is because I'm going to solder it back in when the board's out, and then when I get the board back in, if it doesn't fit, in fact I might just cut it off, hadn't I? What am I thinking? It's getting late in the day, it's red hot, and Pink's flaked out, it's so hot. The dog's flaked out. He's been down to the dog groomers this morning about 7:30 before it got really hot, and he smells like a tart's handbag. And no, that wasn't politically correct. Politically correct statement. But we don't do politics on this channel, so as Terry Thomas says, if that's offended you, oh jeez, oh boy. And look at that. Look at that. It's perfect. We'll have to cut it a bit short, mind you, because otherwise, oh, we will. Let's have a look. Although we could, yeah, I think that's okay. It's not leaning against anything it shouldn't be. Just make sure it, yeah, that fits. That's easy enough to do, isn't it? But that's from the factory. No one's done that. Let's get these knobs off. I'm going to get this board out. Right, I've got the board out, and I've just spotted a dry joint there. Once I got closer on the board, you see that one there? And there's quite a few dry joints. Looks like someone's addressed one there some time ago. But yes, so there's quite a few dry, and that's pin 2 on that preamp tube, so that's obviously a grid. So that could be where our buzzing is coming from. Don't see anything else. Let's just back out. I'm sure there'll be many a dry joint on there. This amp, I've actually lifted the board, just using that so it don't get bottom of the board. Now it's scratched on this, it's a bit sharp. So if you can see, there's a label there. Let's see if we can focus in on him, and I think that's at 2001. Right, I've had a word with the customer, and we've decided to do a full recap on this amp. They're the same capacitors, I can tell from the last one I did anyway, but these caps have been in here for 26 years, and probably best, seeing as he's a regular gigger. He does use this amp for gigs, so probably a good idea to recap it, change all the micas, just make this more reliable. Now I've got the tubes out here, and we're going to give them a test, the output tubes. I've tested the preamp tubes, and they all test like new, apart from the ECC82, but even that tests really well. It doesn't, you know, it's just quarter used, I would say. So you can see the paint how it's gone white on that. So let's pop him in. We need to set this to 1, 6 and 8 and test his 3. So let's check it and see. Yes, you can see there they are there's a bit of life left in them, but not a lot. Normally a new JJ will pin down to about 90 on here, so they've been in since 2020 according to the customer when he last had it serviced. And that'd probably be the same guy that put the diodes on the rectified tube maybe, and that again a good thing to do. But sadly, if you'd have biased this amp correctly, these tubes would be healthy. But they don't look in that way, are they? Let's try the next one. Yeah, look at that. That's only just got out of the yellow. It's creeping up, but they're tired. Tired out tubes they are. Let's try another one. Again, you can see the paint, look, on there. Let's have a look. Try this one. My word. Yes. Yeah. They're not great, are they? They've been baked, and with a touch of cremation on top for good measure. They still work and there's still a bit of life in them, but my word. Yeah. Yes, they're tired. This, as I say, bit of life left in them. One of them's worse than the other 3. Bit of life in them, but yeah. So I look back on the video to the last one I did, and we actually put CV4043 tubes in that amp. The last one I did. They were military grade Mullard tubes, and the cathode resistors were 200 ohms, because for some reason I didn't write that in my notebook, and we changed the screen resistors to 1k, and I've actually got those in stock. I think we put 1k 3 watt in there. So yes, we can do the same on this one, and this one looks absolutely identical to the other one. But the other one, if I remember, that was a Korg one when Korg owned Vox, but this one apparently was made by Marshall after Vox took hold of the reins again. And the good news is I've gone down from 95 on the plankometer to 85 because I've got the schematic that I printed from last time. Right, we've got some parts for this amp. So we've got these are from DigiKey, 47 at 450. So we've got one of those. I've got quite a few of the capacitors that I've found in stock, which we're going to use in this amp. We've got the micas in here. Got various array of bits and bobs. So yeah, that's from DigiKey. That's from DigiKey as well. Got a pack of those. That's for the cathode bypass cap for the cathode resistor there, or both cathode resistors even. So yeah, so we're going to start recapping this now and get it sorted out. Right, we've got the caps in. You can see here going across, and we've got these are 1k 3-watt resistors. We're going to put those in place of those 100 ohms that we had. Pink's seriously on the warpath for food. She's getting savage. And then we've got a couple of 200 ohm resistors to go in for the cathode resistors, and we're going to put a set of CV4043s in this amp, same as the last one, 6BW6. But these obviously, I think these are Brimers, either Brimers and Mullards, military grade tubes, and they go really well in these amps. So Selma used them in some of their amps years ago, and we are going to use them in this, as we did in the last one we did. Right, you can see we've got the cathode resistors in there, got the bypass cap. So getting through all the jobs on this now. I've reflowed one of the tube sockets. I've just got to check the others. Someone's reflowed some of them at some time. So now I've got to get these mica caps out. I've got one here, here, two there, sorry, and one over there. So I'm just going to change them all. We could check on the schematic which one's on the, probably on the tone stack of the, was it the Brilliant channel? Yes, it was the Brilliant channel. This is the Brilliant channel here, and you can see we've got 120 picofarad there. We've also got a 470, so it could be either of those two. So I think I've ordered all of them. I'm just going to change them all, and I've done it. Save messing around. Now the other thing we're going to do is change the tubes on this amp. I tend to see that these modern tubes don't last very long, so I'm trying to find new old stock replacements and things for amps, and these are military grade CV4043 6BW6, used in some of the Selmas in the 60s. Now I've got the data sheet for them here, and we have done this before on the channel, but we'll have a look. So you can see the control grid is pins 1 and 2. They're similar to the old Mullard tubes, so we can just leave pin 2. We don't need to touch. We're connected to pin 2, so that's fine for the grid. Then if we look here, the suppressor grid is pin 9, because on an EL84 the suppressor grid, grid 3, is connected internally inside the tube to the cathode. Pin 9 on an EL84 is normally the screen, and you can see screen grid, grid 2 is pin 8 on this tube. So what we've got to do is swap the screen onto pin 8, which will be empty on here because internal connection is pin 8 on an EL84. So we just move the wire on pin 9 to pin 8. So we just need a wire for the suppressor grid on pin 9, and we connect that wire to pin 3 on the cathode, and externally connect it because it isn't connected inside the tube. So that's all we do for those. Quite easy. Right, so let's get this powered up then. So we've got a couple of 15-watt bulbs in, so 30 watts of bulbs. Let's switch on, and we'll go upstairs there. Have a look. Sorry about the light. There, let's try and turn that off so you can see it. Yeah, so you can see there we've got 129 volts going in. I've got a solid state rectifier in it. We've got the current limiter, sorry, we've got the signal generator going, so we should be looking for some looking for a bit of sound soon. Hopefully 97 volts going into the amp. So let's just have a test around with this meter. Let's see what's across the cathode resistors. Nothing yet. Oops, hang on. Oh yes, we have 0.8 of a volt. 0.8 of a volt. So we've got cathode voltage. See if we've got anything on the screens. Just try the resistors here. Yes, 133. Yeah. Yep. See if we've got it on the screens here. Yeah, and here. Yeah. Good. Let's try the plates. Yeah, 133 on the plates. Yeah. Here's a lumberjack. Yeah. So all looking good. Just can't hear anything coming out of it at the minute. I thought I would have done by now with maybe just let's double the bulbs to 60 watts. So we'll put a 60 watt bulb in, and now you can see and we can hear something now. We just needed a bit more swage, so that's good. And we're on that brilliant channel at the minute. That's what we're plugged into. Drawing 210 milliamps. Got 5.9 on one cathode resistor and 5.9 on the other. That's all looking good. Bringing these caps up nice and steady. Let's go for the 100 watts of bulbs now. So if we go up and have a look, we've got 205 volts going into it now, and you can hear it's getting louder because it's drawing more current. Tubes are conducting better. That's 120 watts of bulbs, so now it's starting to swage nicely. Drawing 340 milliamps. It's just right. Let's just. Well, that seems nice and quiet. The frying, the rumbling's gone. That's for sure. So yeah, the tubes. Bulbs are nice and dim now. So let's drop the 60 and stick another 100 in. That'll give us 200 watts current limiting. That should take us somewhere closer to, where are we, 185 volts going in, and we've got 272 and dropping. So that's the brilliant channel that we had the rumble on. That's now really quiet. Right, we've got the tube rectifier in there now instead of the solid state one. Transformer's a bit noisy, mind you. Might just have to check the bolts on that. So now let's see what bias we've got with the current limiter off. 18.3. Might still be a tad over that one. 18.3 divided by 200 is 91 milliamps. Take away 2. That's 45 milliamps. 45.75. Take away 5%. plate to cathode, 314. 13.6, so we should be 13.2, so we're 0.6 over, which is minimal, but the voltage is nigh on up to 240, so when it's down to like 232, I think they'll be about bang on. So let's just so the maximum plate volts on this is, for these tubes, is 350. Well, we've only got 337 plate to ground. The screen, however, the maximum is 310. So if we go from cathode to screen, we've got 300, and just move my hand, 308. So yeah, it's on the limit, but it's fine, so that's good. So most people run them over, these amps quite a bit, some of these amps quite a bit over anyway, so we're good with that, just like we were on the other one. That's all looking good. So if you can hear, the transformer seems a bit loud when you lift it, it's just with it being in the cradle, but I'll check the nuts just to make sure that it's all tight. I'll check all the nuts. We'll check every nut. Right, we're all finished. Try to tighten these wires up a bit. They're really not brilliantly put together. Sorted out these tube sockets. This one had been soldered a bit rough, so I've reflowed it, cleaned it all up with the alcohol. You can see they burnt that capacitor there with the iron when they went in. Well, it's just the case, it'll run okay. So yes, we're all there. So we've done a full recap. We've changed 3 of the micas, put the CV4043 6BW6 tubes in here. We've upgraded the screen resistors from 100 ohms to 1k, and we've increased the cathode resistors to 200 ohms. The bypass cap has been replaced there, but it's the same value, and that should do us, I think. We've tightened up the power switch, we've tightened up all the bolts on the transformers, done the usual tube socket cleans, and the pots were fine, so I'm not spraying anything into them if they don't need it. Tightened up the ground here, the star ground that was loose, tightened that up as well. So we've gone right through this amp. Now I've also, the retainers on the tubes I've also shortened, because these 6BW6s are a shorter tube, they're not quite as long. So I've actually snipped them and remade them now, so they fit perfectly as well. So the retainers are good. So we're going to get this back in its case, and we're going to have a listen. Right, I've got this Vox AC30 for the demo. So we're in the Brilliant channel. get some very honky tones out of this. Try the normal channel. So I'm stood a bit close to it. Much warmer channel than normal. Let's try the vibrato channel. And the EQ, the bass and treble don't work on the they're not connected on the vibrato channel. The top cut is though. So there we go, the Vox AC30, all back up and running again. So that'll do it for this one. So thanks for watching, you all take care, and I'll see you all in the next one. Bye bye for now.